Okay, we're in the homework on the section 24, and we'll go through the homework certainly. And by this, what I mean is going to go through each problem separately. In the blue area, basically there's some work down there. We'll go through it step by step by step. All right. If I think something's too difficult to understand, I'll try to expand it by writing more work down at the whiteboard for you. But we'll go through this. Number 2 we'll do number 3, and we'll eventually get to the end of the problems, which will be problem number 11. I'm going to switch over to the whiteboard now. Let me just do that momentarily. And give me a second to do this. Give me a second. Something popped up here by accident. Okay, so we're at the homework. This is 24. Okay, so let me get the next page, and I'm looking at it. And what am I looking at? The first problem. And certainly, let me just step you through it. Okay, so it says, find a point C satisfying the conclusion of the mean value theorem. Well, let's say you couldn't remember the mean value theorem. Go back over the notes, look for the mean value theorem. Now, what happens typically on an exam? A lot of students come to an exam and say, "Oh, what's MVT?" And then it really kind of communicates to you that maybe you haven't spent enough time studying. Again, you be the judge of that. But if you're looking at this and I have no idea what MVT is or IVT, you really haven't spent enough time studying. And this happens to a large number of people. They really don't spend a lot of time studying. They think for some reason going to college is somehow going to change them. It's not going to change you, right? It's like sort of like going to the gym. Things going to change you. It's not going to change you. What's going to change you is what you do as an activity. Hopefully it's study time. Anyway, let's go through it. So what's the first thing I got to do? Let me just write this down for you. First thing I write down is, I know what y is. Y is a function of x. And it's the square root of x. And I need to write down its derivative. What's its derivative going to be? Well, that's going to be 1 over 2 root x. All right, that's not so bad. So I got the derivative down. The derivative is pretty easy to write down. Again, for the students struggling with that, I recommend writing this as a power and just using the power rule. All right, now what do? I'm going to write m down. What's m? It's the slope of the secant line between the point, between where x is 4 to 25. So it's going to be f of 25 minus f of 4 over 25 minus 4. Fairly simple to do. F of 25 is going to be 5, and f of 4 is going to be 2. And let's see, 25 minus 4 is going to be 21, right? And what do you get there? 3 over 21, which is 1/7. Now, what's the claim now? We'll be able to find some C on the interval, open interval between 4 and 25, that's going to produce this number, which is 1/7. All right. Again, the square root of x is continuous on the interval between 4 and 25. And the mean value theorem, we got the slope of the secant line through those endpoints. We'll be able to find a C contained in an open interval between 4 and 25, such that the slope would be 1/7. So what do we get over here? Well, let's write down. So it's going to be 1 over 2 root C. Let's see if we can do that. And just basic algebra. So 2 root C would have, I'm sorry about that. 2 root C would have to equal 7. I'm just looking at that equation over there. Square both sides, what do you get? 4C equals 49. And what's C? It's 49 quarters. Right? Now someone says, what's 49 quarters? Well, if you thought about it, it goes in, let's see, 12 times with the remainder of 1, 12 and a quarter. Is that between 4 and 25? Of course it is. Mean value theorem guaranteed it, by the way. So what's my number? C is 49 quarters. All right, right over here. Let me go through the work with you. That's written in the blue area. Probably it'd be better if you could look at the blue area after working the problem. The function is continuous on the interval 4 to 25. We did mention that to you. This is the function. This is its derivative. This is the slope of the secant line between along this curve between 4 and 25. We solved the equation where the derivative value at C would equal 1/7, and we found it to be 49 quarters. Again, that work is over there. We got the 49 quarters. Let's do number 2. Number 2 is a little more complicated. And I'll tell you, because I'm going to look at a picture. So what I got to do is I got to get to the picture, and I'll just copy the picture right over here. And let me just copy it. And let me go back, and I'm going to paste it in. All right, so let's paste that picture in. And let's talk through it. And we're going to do one thing at a time. I'm going to do A first. Right, I'm doing A first. Now, what does A say? A says that this function that they've got here graphed is actually the graph of the derivative. So I'm going to write that down for you. So this graph over here is actually f prime of x. All right, so they tell me what f prime is. This is the graph of it. All right, so it says determine the intervals. Oh, I'm sorry, they didn't say it. It's the graph of f. I apologize. I didn't read that. Let me just back up a little bit. It's the graph of f. All right, so determining intervals in which f prime is positive. Well, let me go through this with you. F prime would be positive when the function is increasing. So where is it increasing? It's increasing here. And it's increasing here. Now, some students may argue with this. They say, oh, I can't get those numbers. You're looking at the numbers. So I'm going to say, if this is the function f prime, I'll write this down for you. F prime of x will be positive when the function is increasing. What are those intervals? Well, let's write this down. Hey, looking at it, it looks like 0 to 1. And where else does it look like? It looks like 3 to 5. Let's look at our K. And what does it say? It says determining intervals f prime is positive. I did that. And where it's negative. I haven't done that yet. Where it's negative when the function is decreasing. Here and here. Where is it decreasing? Let's write that down. It's decreasing between 1 and 3, and it's decreasing between 5 and 6. Let's see how we did. Let's look at the answer key, and the answer key is over here. F prime, whoops, sorry about that. I'm a little sleepy right now. F prime is positive 0, 1, 3, 5. I got this written over here. F prime is negative, right? F prime is negative. I'm writing that over there between 1 and 3 and 5 and 6. That's good. All right, let's go to the next problem. This problem over here. I'm just going to pull this into the next page because that's where the answer is. Let me just copy it and give you a second to do so. And look at the next page. All right, I'm going to paste it over here. And I'll try to do a better job of reading. All right. So what do they say now? And let me pull this over here. It says determine the intervals on which f of x is increasing or decreasing, assuming the figure is the graph of f prime. All right. So it pays to read. So what do I know about this graph over here? This graph over here is the graph of f prime of x. So what I'm going to do is I'm going to write down, where is f prime of x positive and where is f prime of x negative? All right, let's take a look at that. Let's do the positive part first. It's positive, let's see, here. And it's positive here. So I'm going to say the derivative, right, this is f prime, is positive between 1 and 2, and it's positive between 4 and 6. Now, where's its negative? It's negative over here. And what is that? Well, let's write that down. It's negative on the interval between 2 and 4. Now, what's their question? Their question is determine the intervals on which f is increasing. Where is it increasing? It's increasing when the derivative is positive. So this is where f would be increasing. We'll look at the key later. And this is where f of x would be decreasing. All right, let's look at the k. And so when you look at the key, I just want to make sure I read it right and I didn't make any mistakes. So let's say f of x is increasing. on the intervals between 0 and 2. Am I reading the right thing? Oh, you know what? I wrote down something funny here. That's not 1, it's 2, it's 0. I have to correct that. I'm glad I read that. Right over here, that's 0. Sorry about that. I'll reread it again. So let's go back to my thing. It's increasing on 0 to 2. I do see that. And 4 to 6. Again, this is 0. I don't know why I said 1. I clearly have written down the red that's 0 to 2. And then 4 to 6. Let's see if I got that right over there. Yep. And it's decreasing on 2 to 4. Done. Let's go to the next question. And this is question number 3 now. And number 3, looking at it, so, find the critical points of the function. I want to point out, I could do this in Math 100, although they didn't call it a critical point. What I want to claim is this is a parabola that opens downward. And the vertex, really easy to write down for that for your Math 100 days. Let's see, that's minus b, which would be minus 2 over twice a, which is minus 2. So the vertex would be at 1, comma, that would be minus 1 plus 2, which is 1, 6. That's where the vertex is. What do I know about this thing over here? We're looking at it, and this is without using any calculus, increasing here, and it's decreasing over there. So if I were just going to do the calculus, I'd say increasing. This is, by the way, this is a global, whoops, I'll go back to black ink. This is a global and a local max. The function is increasing. We'll go to the calculus later on the interval from minus infinity up to 1, and it's decreasing on the interval from 1 to infinity. All stuff that you've done in prior courses without the use of calculus. Now, of course, they don't want me to do that, but I could read this, and do the problem they want me to do it. How they want me to do this thing? By using calculus. So find the critical point. Let's go through that. And I'm going to say f of x, write this down for you. F of x is minus x squared plus 2x plus 5. I'm going to say the domain is all real numbers. And let's put its derivative down. And that's going to be minus 2x plus 2. It's never undefined, but it does become 0. F prime of x does equal 0 when x is equal to 1. Number line goes down. This is the derivative. I got a critical point at 1. I'm going to look to the left and right of it. And again, what I'm talking about over here is we're looking at analyzing a derivative. This is sign analysis, something you learned about in Math 119. You have to put a number like 2 over here. What kind of number you get? By the way, 2 is to the right of 1. You would get a negative number. So I know this side is negative, which means the function is decreasing. And if I took a number to the left of 1, like 0, plugged it in, it would turn out to be a positive number. We're plugging into the derivative, which means it's increasing. Now, what does this indicate to me? Well, just looking at it, certainly indicates a relative maximum there. But you look at my picture, I know it's global, right? So what's critical number? The critical number C is 1. The critical point is going to be 1, comma. You've got to plug it in here to find the point. And if you plug in 1 there, I hope you get 6. At least I got 6. We'll check with the key later. And what else do they ask is, basically, what is it? It's maximal. What kind of max it is? It's global. It's also local. Okay, let's take a look, see how we've done. All right, so looking at it, I got the derivative down. I got the critical point. The critical value C is 1. I did some simple sign analysis, indicates the points of maximum. I got that down. All right, let's look at number 4 and just reading through it. And again, I'm doing the homework as if I were a student in the class. And certainly, I don't think I'd be talking to myself as a student in class, so I hope not. Domain, all real numbers, polynomial, right? So I'm going to write this down for you. Domain, minus infinity to infinity. And let's put the derivative down for you. And doing that, you know what? They got it written down. It's pretty easy to do, right? Let's see how they did. So they wrote the function down and they wrote the derivative down. Let me check the derivative for you. 4 would come down. They get 3x cubed. Looks good. 6x squared looks good for the second term. Third term, 2 would come down. Cancel the 2. You get 3x minus 6. And I'm going to go over this now with you. I'm going to go over the factoring of it. So why would you factor that? Because it looks factorable. And let me write this over here. So 3x cubed. This is the derivative. Plus 6x squared. Minus 3x. Minus 6. And I think I want to factor it. And what do you get there? I'd say 3x squared. That would give me x plus 2 minus 3x plus 2. Gee, I got to factor out x plus 2, right? X plus 2. And I'd be left with 3x squared minus 3. I'm seeing a 3 now. Let's pull that out. By the way, I saw the 3 in the beginning too. So 3x plus 2, x squared minus 1. Wow, this is going on. X plus 2, x plus 1, x minus 1. Let me just go through that. I see that over there. Now, before I do anything else, which I do have to go to the next page, is I want to read the question and find the critical values. I found them, and I'll write them down for you. So the critical values, and let me write them down separately, and it's acceptable to do this. The C, whoops, I keep doing that, don't I? The C could be, let's see, minus 2, minus 1, and 1. All right. Now, what I like to do is, I know they said the critical points, but I'll be honest with you, I'm not that interested in computing them at this point, but I do want to write down the critical points. These are the critical values, but I'm going to write down the critical points now. And what are they going to be? Minus 2, f of minus 2, minus 1, f of minus 1, and 1, f of 1. Now, someone says, are you interested in computing those things? Yes, certainly. But I'll be honest with you, I really don't want to compute them. And the reason for that is it might take, too much boring time away from what I'm talking about. I think you should compute them. You need practice arithmetic, but I'm not going to compute them for you. I do want to point out, though, if you're having trouble with arithmetic, you can always come by during office hours and we could assist you, including telling you how to remediate those problems. Although I'll be honest with you, they're hard to remediate if you have not learned arithmetic at this point in your life. All right. And so I'll use a calculator. You realize most exams in most universities, they're not letting you use tools except for paper and pencil. All right. So I'm going to say I'm good with that. Now it says determine intervals where f is increasing, decreasing. Well, I got to do that now. And that for a lot of students is going to be the tough thing. All right. And I'm brief that the background in 119 was not sufficiently well understood. And that's basically sign analysis. So I put a number line down. This is derivative, and I'm going to analyze the derivative. Now, what do I put down? I put all the critical numbers down, and the critical values are going to be minus 2, minus 1, and 1. And this is the derivative over here. And it's really easy to analyze that derivative. And why is that? You take a test point. Like, for example, what's a good test point between minus 1 and 1? I'd say 0. If you plug 0 into this expression over here, let me clean it up for you. Whoops. That's a plus sign. And this is minus 1 over here. Let me get my eraser out, make it look cleaner. All right, I'm going to plug 0 in. Here, positive, positive, positive. That would be negative. Overall, it's negative. What does that mean? Decreasing. I'm going to take a test value over here, like 2, plug it in, plus, 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 plus. Everything is positive. This means decreasing. This means increasing. By the way, when we say that, we're talking about f increasing, decreasing. All right, now I'm going to hold off between minus 2 and minus 1. And to read that, I want to go to something a little bit easier, like minus 3. Positive, negative, negative, and negative. All right, let me repeat that. 3 is positive. This would be negative. This would be negative. And this would be negative. Overall, it's negative. What does that mean? F is decreasing. And we'll write this down later and we'll look at the K. All right, now between minus 2 and minus 1, what's a good test point? I'd say minus 1.5, right? Plug it in. positive. Minus 1.5 plus 2 is positive. This would be negative, and this would be negative. So overall, it's going to be positive. Again, if you're struggling with sign analysis, you need to come by during office hours so we can help you with that. All right. Now, someone says, I never really even thought about doing that before. It's important you start to learn. And you have done this material prior to this when you did Math 119. And 119, you started off with sign analysis when you did inequality, but this is increasing over here. So I'm going to write this down. So f of x is increasing. You also did increasing, decreasing in Math 119. So I'm going to say it's increasing. And I'm just looking at the f prime thing now. It's increasing between minus 2 and minus 1. Where else is increasing? 1 to infinity. And f of x is decreasing. Well, where's it decreasing? Let's take a look at it. Minus infinity up to minus 2. And where else does it decrease? Between minus 1 and 1. All right. So what I recommend you do, look at the answer key. I really mean that. Look at the answer key. I'm going to the next page, and I'm going to pull it off. And I'm going to, because I realize sometimes you look at that and say, well, I wonder if that's right. Well, let's take a look. I'm going to edit, copy, delete it, go back to the other page. And I'm going to paste it in right over here. Give me a second to do so. Blow it up a little bit. And look at my answers. Let's take a look at it. It says the critical numbers are minus 2, minus 1, and 1. Gee, I got that right. Simple sign analysis in the first derivative indicates the maximum occurs. Well, you know what? I don't think I put that down. Let me just pull this down a little bit. So I'm going to say, maybe I should write that down now. And let's take a look at it. And I'll point this out. Maximum, this is a hilltop, right? This is a peak, would be at minus 1. Max. At whoops, I had to pull this down. At minus 2 and 1, it's a min. By the way, these are local. All of these are local. You should have a good idea about this because this is a fourth degree polynomial. And I'm not going to commit to the global nature of it until I get a picture of it. But I'm going to say local. It's got just every left and right of all those points over there. So let's take a look at it. And it says, critical values. I got that part. Simple last first derivative indicates the maximum occurs at minus 1. Let's see if we did that. That's right here. Right? Let's keep reading it. And minimum's at minus 2 and 1. I got those written down now. All right. Again, valleys. That's where the minimum occurs, and peaks over here. Okay. Let's go to the next one, which is going to be the next page. Okay, number 5. Now, number 5, when I'm looking at it, again, I'm going to go through step by step. And I notice there's some work written over here, and I'm going to go through it with you. And certainly, again, it does require some basic knowledge of prior material. Calculus requires arithmetic and algebra and pre-calculus material. It does, it requires it. You might say, could I skip that, go to calculus? No, you can't skip that. You need to know that. So hopefully you're not struggling too much with the basic stuff. Okay, let's go through it. The domain of the problem is all real numbers. All right. It's a difficult curve, though. I'm not saying it's not. What I would do, though, I would not do anything except simplify the problem. And the way I would do that is I would just simply say f of x. I would actually multiply this out first because it makes it easier for me to do that. And how do you multiply that? X to 1/3, x 2. You have to add the exponents together. So that's going to be what? 1/3 plus 2. Well, 2 is 6/3. 6/3 and 1/3 is 7/3. Plus 15x. Well, if you did that, that's going to be x 1 plus 1/3. That's going to be 1/3 plus 3/3 is 4/3. And then you get minus 100 x to the 1/3. And someone says, why would you have done that? It makes it easy for me to take the derivative. Let me write the derivative down for you now. So f prime is going to be 7/3. X, let's take 1 away from that. That's 3/3. That's 4/3, right? And then it's going to be plus, well, 4/3 comes down. That would be, let's see, 3 goes to 5. 5 times 4 is 20. X to the 1/3. All right, I keep going. Minus 100 thirds X. Like you need to take 1 from that now, right? That's minus 2/3. I'm going to do something that some students actually find strange. I'm going to factor out the negative power and the fraction. And the fraction I'm seeing is 1/3. So I'm going to factor out X to the minus 2/3. And I can factor out 1/3. They're nightmares for me. That's why I factored it out. And what are you left off with? 7x. Well, it's going to get a tough one now. So what's going to be? It would have to be 6/3 to make it a 2/3, right? No, I'm sorry, 6/3 because minus 2/3 to make it 4/3. So I'll say 6/3. That's 2, isn't it? Again, 2 is 6/3. 6/3 minus 2/3 is 4/3. That looked pretty good. Plus, well, I didn't have 1/3 in it, did it? So that'd be 60 then, wouldn't it? Because 1/3 of 60 is 20. Now what would I have to put down? I guess 3/3, because 3/3 minus 2/3 is 1/3. And what's 3/3? It's 1 minus 100. All right. Now I'm going to say, I always wonder, did I make a mistake somewhere? Did I do something wrong? And you should be saying that to yourself constantly by looking at the K. So I got this. You know what I mean by that? I'm seeing this over here. And I think I got the derivative down. Let me make sure I got the derivative down. 7x squared plus 60x minus 100. Not bad. Over, well, they wrote this a little bit differently. They wrote the power at the bottom, but it's still the same thing. And this is good news for me. All right. Now, I also notice they factored it. And someone says, why would they factor it? Well, I think it's important to factor it. And the reason the sign analysis, it depends on factorizations. Let's write this over here. And the bottom is going to be 3x to the 2/3. And I'm going to try to factor the top. I'll look back at the key later. And I'm going to say 7x times x is 7x squared. I know it's tough. I'm not saying this is going to be easy for you. And a lot of people say, I can't do it. I can't do it. I can't do it. You can give it a try. All right. 100, I'd say 10 and 10. I'm not saying it's right. And I would say, let's see, plus 10 minus 10. Let me see if this gives it to us. I don't know. 7x times x, 7x squared. That worked. It always does in trial and error. Then you get 7x minus 10x, which is 60x. A miracle. I got the middle term and I got the last term. Now I can write down the critical numbers. And what are they? They're super simple. And let me write these down for you. So the critical numbers are as follows. C equals, well, the first factor, 7x minus 10 becomes 0 when x is going to be 10/7. The next number that would make that a 0 on top would be minus 10. Now at the bottom, that becomes 0 at a certain number. And what does become 0 when, let me put these down as x instead. I'm sorry about that. But no, they are critical. I'll put C. C, C, C. And what's that going to be? Let's see, 0. That's not so bad. Number line goes down. And these three numbers, you don't have to have them equally spaced. You put them on any way you like. Just put in proper order. That's about it. And this is going to be F prime. All right. So what are the critical numbers? I got 0. I have minus 10. I want to point something out to you. The distance between these is 10 units. Now, someone says, well, you made this an equal distance. It doesn't matter. I just got to get in the right order. But I know that 10/7 is 1 3/7. So it's not 10 units. I know that much. But I like to leave some space over here. And what's this number over here? 10/7. We'll look at the key later. I can take some test values for you. And what I mean by that, easy ones. So what's a nice easy number between 0 and 10/7? I'd say 1. Plug it in. Positive, positive, positive. Wow, that was easy. What does that mean? The function is increasing. All right, let's keep moving. Now let's go. Oh, you know what? I just made a mistake. I just saw it. Let me erase this. It happens sometimes. I'm glad I make mistakes. I'll tell you why I'm glad I make mistakes. If I'm making mistakes, you're going to make mistakes. Go back to my pen. I think I said 1, right? And this is what I said. If I put a 1 there, I get a positive number. That's crazy. And why is that? It would be 7 minus 10, which is a negative number. This would be positive. So this interval is negative. Sorry about that. It means it's decreasing. Now, when I say it's decreasing, the function is decreasing. Now, what's a good number after 10/7? I would say a number that's safe, like 2 or 3 or 4 or 1,000. Any number after is going to work. So I'll plug it in. And if you plug it in, what would you get? Like if you plugged in 2, positive, positive, positive. Everything's positive. What does that mean? Increasing. We'll look at the key later. I don't even remember the questions anymore. Now, what's a good number between minus 10 and 0? I'd say minus 1. Got to plug it in. This would become negative. This would become positive. Now, I hope you're not struggling with these powers over here. But if I put a minus 1 over here, I'd be squaring it. So this bottom becomes positive. The fact is, the bottom will always be positive. Always, because I'm squaring it. It's always positive. Now, when I say that it's 0, it's 0, but the numbers beyond 0 are always going to make this thing positive. So let's go back over here. Minus 1 would make this negative, this positive. That's going to be negative, right? Let me repeat that again. Negative on top, positive on bottom. It's negative. Now, this upsets a lot of people. They said that shouldn't be. Well, that's what it is. They want to do this as a guessing game. This is not a guessing game. This is plugging in. Let's take a number below minus 10, like, I don't know, minus 11, plug it in. This would become negative, this would become negative, and this is always positive. So what do we get? A positive number. Again, if you're struggling with sign analysis, you're struggling with Math 119, 2 courses before this one. I'm not saying you can't struggle with it, but you got to get it fixed. You got to get this fixed. Let's go back and see what the question was. What's the question? Find the critical points of the function. Let me write the critical points down for you. The critical points, CP, are going to occur where x is going to be 10/7, f of 10/7. No, I'm not going to do that. Minus 10, f of minus 10, and 0 and f of 0. I got that covered. I said find the critical points. I've done that. Use the first derivative steps. I've done that to indicate the points that are going to be minimum or maximum. I'm looking at this thing, and I'm going to write this down now. So let's write this down one at a time. And what's this thing over here going to give me? This is going to give me a maximum. Where did it occur? At minus 10. This is going to give me a minimum. This over here is a minimum. Now someone says, I wonder what's happening at 0. Something strange happening there, but it's not a min or a max. The function is decreasing there on that entire interval. Between here and here, it's decreasing. Let's look at the picture. Hopefully it'll elucidate what we're looking at over here. So I'm looking at the picture, and what I'm going to claim over here, just looking at the picture, and blow it up for you. And it's nice to have a picture because I'm looking at it, and there's a maximum here. Where did that occur? At minus 10. What's over here? A minimum. Where did that occur? At 10/7. What's 10/7? It's like 1 3/7. And that clearly looks like 1 3/7 to me. What's happening over here? There's actually a vertical tangent line at 0. All right. That's kind of clearly indicated over there. And this is the graph. All right. Let's see if we've done. Look at the blue area. So the critical values are x equals minus 10, 0, and 10/7. Let's see how we did there. Let's see, minus 10, 0, and 10/7. Simple sign analysis, which we've done the first derivative. We've done that. Indicates a local maximum at minus 10. I've got that covered. And a local minimum at 10/7. And I got that covered. All right. It says the graph is being provided to you. And it does claim there's a vertical tangent, x equals 0. All right, it's a good idea to look at that. All right, I got to look at number 6 now. And number 6 is, find the critical points of it, yada, yada, yada. Well, let's take a look at this. So domain is all real numbers. And let's write the derivative down. Oh boy, I'm gonna see if I can do that. Let me go on the side. I'm gonna use it. I'm gonna use the quotient rule. It's gonna be x squared. It's gonna be minus x squared plus 4 squared x squared plus 4 times the derivative of 5, which is 0, minus 5 times the derivative at the bottom, which is 2x. I think I can write this down. Which is going to be what? Minus 10x. But minus 10x is 10x, isn't it? And what do you get on bottom? X squared plus 4 squared. All right, hold that thought. I'm going to the next page. All right, let's go backwards. I said 10x over x squared plus 4 squared. That's what they got. I'm glad. So what am I going to do? Well, I got to get the critical value of here. I'm going to repeat this. We're looking at f. And f is pretty simple function over there. Let me just erase a little bit. F of x, the domain of this is all real numbers. What's critical value? There's only one. And what's that critical value going to be? 0. This is the derivative. Let's analyze the derivative. After 0, pick a number like 1, plug it in, positive. Take a number below 0 like -1, plug it in, it's going to be negative. Decreasing, increasing. So I got a critical point. What's critical point going to be? C is going to be equal to 0. What's critical point going to be? 0, f of 0. By the way, I noticed that f of 0 is really easy to compute, so I'll write that down for you. What's going to be? -5/4. All right. What is that point? It's a minimum local. By the way, when we start to graph it, we'll turn, global or not, but I'm not too concerned about that. That's a local minimum. What do they got over there? Let's read it. Critical point 0 -5/4. I got that right. Simple sign analysis. I did do that for you. First derivative indicates the point is a minimum, and that's written over there for you. All right, let's go to the next one. A little more complicated. And I realize that for a lot of students, it's the trig that's really a killer. Not only does algebra kill them off, but trig really kills them off. It's the kryptonite. I always say that things that really affect students greatly are, fractions hurt students, algebra, and also trig. It's hurtful, right? What I notice about this over here, they give me the domain of the problem. I'm going to write this over here. The domain of this problem over here, domain, is given to me as between 0 and 2 pi. Now, if it wasn't given to me, the domain of this thing would be far more complicated. It would be all real numbers. And that's a really big line to look at because this is a periodic function. It keeps going up and down, up and down, up and down, up and down, up and down. I'm glad they restricted it to 0, 2 pi. So what am I going to do? Well, I'm looking for those critical points. So what I'm going to do is I'm going to get the derivative. And what's the derivative? It's really easy to write it down. So I'm going to write down y prime. It's easy to write that down. It's going to be 5 plus 5 cosine theta minus 5 sine theta. Right? I'm going to red pen out and see how we did. Well, y is given. I can't get that wrong. Did I get the derivative right? I did. I see 5 plus 5 cosine theta minus 5 sine theta. My trouble now is finding out the critical numbers. And let's go through that. All right. So I'm really trying to find the critical numbers. Now, if you think about it, it's only on interval between 0 and 2 pi. So what am I looking at? I'm looking at an equation to solve. When is it on to 5? When is it equal to 0? Well, it's always defined an interval. When is it going to be to 0? Let me write that down for you then. So when is this equation? When is y prime equal to 0? Well, let me write it down. What do you get? 5 plus 5 cosine theta minus 5 sine theta equals 0. What I would do, and again, this is me, you may say, I wouldn't have done that. I want to do something different. I actually want to encourage you to do things that are different if they're right. If you're doing things that are wrong now, I got to strongly discourage you from that. Really strongly discourage you from that. What I'm going to do though is divide both sides by 5. And what would I get? 1 plus cosine theta minus sine theta is equal to 0. I divided both sides by 5. I got to be honest with you though. This reminds me of things you had in Math 120. So I'm going to try to solve it. I'm not saying it's going to be easy for you, but here's the deal. We are never going to give you something you can't do. Keep that in the back of your mind. That's nice to know. We are never going to give you something you can't do. It's like being at a carnival where there's a ride, and the message on the beginning is, we're never going to put you on a ride that's going to hurt you. I'd go on all the rides then. Unfortunately, they don't say that at a carnival, because you might get in a ride, you might get horribly damaged. Let me write this down now. I can try to solve it. And it looks tough to me. I'm going to solve it for 1. What do you get? Sine theta minus cosine theta. I am now going to square both sides. What do you get? 1. This looks like it might be tough. Sine squared theta plus cosine squared theta. Oh, it's going to be more work. Minus 2 sine theta cosine theta. Yeah, you need to know trig and algebra to do that. Pythagorean identity, 1 equals 1 minus 2 sine theta cosine theta. Well, that looks pretty easy. What does that mean? 0 equals minus 2 sine theta cosine theta. And then what does it mean? It means sine theta times cosine theta has to be equal to 0. So I got to be honest with you. I think that might be easy to do because the product, and when would that product equal 0? Whenever these factors are equal to 0. So you have to understand, we're on the interval between 0 and 2 pi. Now, when would the sine function become 0 between 0 and 2 pi? At only one position. And what would that be at pi? All right. So I know the sine becomes 0 at pi. When does the cosine of theta become 0? And I got to put this down over here. So let's take a look at that. That would be pi over 2 and 3 pi over 2. These are things you learn in Math 120. And here's another problem. You did something, I'll be honest with you, that was incredibly dangerous. And I want to point out what you did. You squared both sides. And you should remember back in Math 120, when you did that, you might have introduced an extraneous solution. So what I got to do is check these. I'm going to check them one at a time. Where would I check it? Right here. Let me check pi out first. I'm going to check. If it doesn't work, I'm going to cross it out. I'm going to check pi first. If you plug in pi, what would you get? 1 plus, what's the cosine of pi? That's minus 1, isn't it? And what's the sine of pi? 0. Does that equal 0? It does. Good answer. Let's try pi over 2. I don't know. Maybe it doesn't work. What do you get? 1. What's the cosine of pi over 2? 0. Minus, what's the sine of pi over 2? 1. Does that equal 0? Yes. That checks. Let's check this one. All right, I'm checking them all. I'm going to check this one now. I'll push this over here. 1 plus cosine 3 pi over 2. Well, that's 0. Minus the sine of 3 pi over 2. That would be minus 1. Does that equal 0? No, it equals 2. This can't be true. So I got 2 critical values. Now someone says, I could do that with all that work by just looking at the problem. I'm not opposed to it. Look at the problem. I know what the answers are. There's only 2, pi over 2. So I know my critical values, and I'll write them down for you. They're going to be c equals pi and c equals pi over 2. All right. Let me put my sign analysis down. I know it's tough, but I want to encourage you to try. And this is going to be between 0 and 2 pi. And I don't know, pi is in the dead center, right? And pi over 2 is right over here. All right. So what are you going to do now? I'm going to analyze it. By the way, before I do that, I want to go back and read the question to you. They want me to find the critical points and analyze the function on the interval. And I'm going to do it. I'm going to do it. And what am I going to do? I'm really looking at the derivative. And I want to point out what I mean by that. I'm looking at the sign of this thing over here. That's all I'm looking for. Now someone says, could you put fives down there? Of course you could. It's not going to change the sign of it. All right, let's talk about it. All right, let's talk about it. And someone can say, what number are you going to pick? Easy ones. Really easy points. I'm going to point them out to you. More difficult. I'm also going to write down in degrees. I'm going to say 270 degrees here. Now, what's between those two? That's between 90 and 180. I'm going to say 100, and let's see, 35 degrees. What number am I going to pick over here? I don't know, 45 degrees. Let's do it one at a time. And I'm plugging it in again here. I want to get the sign of it. It's either going to be positive or negative. What do you get? 1 plus 1 over root 2 minus 1 over root 2. What kind of number is that? Positive. Increasing. Let's go to 270 because I find it easier. I really do. I mean it. I find it easier. 1 plus, what's the cosine of 270? Right? You may have to think about it. That's going to be 0, right? And what's the sine of 270? Minus 1. That's minus 1, which is plus 1. That's positive. Well, let's do 135. What do you get? Ready? I'm doing this one. 1. Again, I'm doing it over here. Minus 1 over root 2. Minus 1 over root 2. All right, this might be more difficult for you. Let's keep going through it. And let's see, you get 1 minus 2 over root 2. Common denominator, root 2. What would you get there? Root 2 minus 2. Well, I hope you know now that root 2 is definitely smaller than 2. So a number smaller than 2 minus 2 is definitely going to be a negative number. All right, let's summarize. I've got 2 critical points. Let's write them down for you. The critical points are going to be as follows. Pi over 2, comma, let me see if they used F. No, I'm going to say y of pi over 2. No, I'm not going to compute it, but I can. What's the other one going to be? Pi, and that's going to be y of pi. Yes, we can compute it, but I'm not going to compute it. Okay, what is this one over here? Pi over 2. Well, look at it. And what do you see over here? That's a max. Now, by the way, definitely local. We'll talk about global and all that stuff later. This over here is a min, just by looking at it. It's a valley. It's a local min. All right, let's look at our answer key. And let's see if they did the same thing. You know, I got the derivative right. I know that much. The critical values are pi over 2 and pi. I got that right. Simple sign analysis, first derivative indicates a local minimum at pi. I got that covered. And a local maximum at pi over 2. And I got that covered. Not bad. We did all right. All right, let's go to number 8. Number 8. It says find the critical points of the function, first derivative test. Boy, we've been doing this over and over again. Test critical point, local maximum, local minimum. Gee, we've been doing this over and over again. Determine this when function is increasing and decreasing. All right, let's go through it. But what I'm going to do is go to the next page. And the reason for that is the answer key is there. Let's go to the very next page. And I'll go through the work. I'll give you 1 second to do so. And I push this over. And I'll start putting the work down for you. And what's the work going to be? Domain. Whoops. The domain of this is all real numbers. All right, what's the next thing? But the derivative, it's not so bad. And what would you get there? 8 minus 7e to the minus 7x. That wasn't so bad either. Now this derivative here is defined everywhere, but it's 0 somewhere. So I'm going to figure that out. When is it 0? It's 0 when this 8 is equal to 7e to the minus 7x. I'm going to keep working on it. Divide both sides by 7. I get 8 7s equals e to the minus 7x. Now it's going back to 119. I got to solve the equation now. And I'll do that by taking natural logs. The natural log of 8/7 is equal to minus 7x. I'm going to keep writing it. And what do you get over here? Let's take a look. I have to divide by minus 7, right? So it's going to be minus 1/7 times the natural log of 8/7 is equal to x. So let's put our number line down. Number line down, we're analyzing the derivative. There's only one point I have to worry about, and that's going to be this guy over here, which is going to be, let's see, minus, oops, sorry about that, minus 1/7 ln 8/7. Now, by the way, if you're looking at a textbook, they may rewrite that guy, and I'll write down what else they could write over here. This is also the same thing as saying 1/7 the natural log of 7/8. So it depends. If you look at that, say another book wrote that down, they're both the same. All right, they're both the same. What happens to a lot of students now is that they have no idea what number to pick. None whatsoever. Right? And they got to use a computer to do it. I'm going to say, I don't think it's a good idea, but I understand it. Sometimes I look at things and I say, I don't know what number to pick either, but I want to pick a number like over here that I believe is really safe. I'm going to say 1 billion. Now, that sounds outrageous to you, but I'm going to say 1 billion. That's a really big number, right? And let's look at our derivative. This is our derivative. If you plugged 1 billion in there, what kind of number would you get? Well, you get 8 minus 7 e raised to the minus 7 billion. That would be an incredibly small number. So what do I get over there? This would be positive, which means the function is increasing. All right. Now let's go below that natural log number. Let's go below it to a really safe number. I would do minus 1 billion. Minus 1 billion over here. That might sound outrageous to you, but I know for safety reasons that's there. And what do you get now? Well, if you put a minus billion into this derivative over here, you would get e to the 7 billion, which is an incredibly large positive number. And what would you get over there? 8 minus 7 times an incredibly large positive number, and that would be negative. So I did my simple sign analysis, and now I'm ready to commit to where this function has a minimum. And I'll write this down. So the critical point is going to be, let's write this down. It's going to be, let's see, minus 1/7 natural log of 8/7, comma, I really don't want to compute it, f of minus 1/7 natural log of 8/7, right? And what is it? This is a minimum. I'm going to say local. By the way, we'll have to graph it out to get more detail on that, but right now it's local because there's things left and right of it. Let's look at our K, see how we did. And I really mean it. I can't say it sometimes. Please look at the K. Please look at the K. So it says the critical point minus ln 8/7 divided by 7. Did I say that? Yep, I said that. That's good. It said simple sign analysis in the first derivative indicates the point is a minimum. Did I say that? Yep. Let's keep going. It says it's decreasing from minus infinity to that number. Did I say that? Yep. It said over here, it's increasing from that number out to infinity. Did I say that? Yep. All is done. All is good. Let's go to the next question, number 9. We're moving through this pretty quickly. I know that. And this one says find the critical point of the function, first derivative test. Boy, this is getting sickening. So I got to tell you something. This looks like a really easy problem to do. All right. And someone says, why do you say that? The arctan's derivative is really, really, really nice. Let's write this over here. So f of x is 4 times the arctangent of x minus 2x plus 2. F prime is going to be 4 over 1 plus x squared minus 2. That was easy. I like to write it as 1